attending one of the last talks. Intelligent Waste Separator is by Engineer Andrés Torres Garcia. His supervisor is Omar Humberto Longoria. He's a student of Ingeniería in ITES. So please.
Okay, thank you very much. Well, my name is Andrés. This paper is about the construction and building of an organic separator of trash. So, going to start. Okay. Well, this is the motivation of this, the construction of this separator, is that the garbage is a global problem. So in Mexico is not a exception. So Mexico is one of the top producers of garbage in Latin America, and alone produce 840 tons of garbage per year. So this is the motivation of this project. Okay, well, as we can see in this chart, the most the waste that the most generates is the plastic bags, next PET bottles, and next cans. So with this information, we choose this kind of object to separate first. Okay. So well, the specific problem of this is that people don't know or doesn't separate well the waste that you put in the different container that has a specific for a specific container you put a specific waste. So people doesn't respect, or despite of the signs and world markets containers, these are always mixed trash. So that's why one of the problems that we face, as you can see here, is mixed. So people doesn't respect that. So that is the motivation to build a machine that can separate automatically the waste that we generate. Well, the proposal is to have a unique trash can where you can insert the waste, and automatically inside the machine separates the waste in each container of this, instead of having a lot of multiple trash cans that is a lot confusing for people. So well, the main features that the system will have is well, first we choose cans, plastic bottles, and plastic utilities to separate. So only separate these kinds of waste. And also, well, in order to incentivize the people to use our system, we give for each waste deposited in the machine points that the user can exchange for any kind of product. Okay, well, the system is designed only to be used in public areas such as downtown areas, school parks, and malls. It's not for user purposes. So, this is the scope of this machine. Well, this is the block diagram of the system. Here we have where you deposit the waste. It enters in a camera where a photo is taken from a webcam. We are using a webcam, and here we have the samples taken from inside of the prototype. Here we have the plastic bottle. Next we have the aluminum can and the plastic cutlery, and next passes to we are using an atom processor. So it's low power, this machine. And also, well, it computes the image processing of the image. And, well, we are using here to identify the the object, we are using object recognition, vision. Next, in the next slide, I'm going to explain the algorithm used for this approach. Well, next, the Atom will send commands to the serial interface to power the motors. We have like 4 DC motors to power each gate. So depending on the type of the waste is the motor that will be open. Well, also we have a LCD touch, like a feedback for the user to view which type of waste is deposited, and also give the points for the waste. Here we have an RFID sensor because we are working with magnetic cards. So each time you deposit a waste, you pass your magnetic card and you obtain the points.
So, you pass the card to get credit, so in your favor. What means passing the card?
Just passing the cards to the RFID sensor that we have, like the ones that you are using to enter to a laboratory.
Right.
That kind of technology we are using to get the points. Well, this is the process in above terms. First you deposit the waste, and the machine examines the waste, and well, you see, and asks the question if it is a can, or if it is a bottle, or it's a cutlery. If object is not recognized, it's not going to open anything, so it won't give you any point. So depending on the type of waste, it will be open the correct gate for that particular waste. So next, finally, the system gives you points according to the type of waste, because it's, well, you know that aluminum cans are the most have the most cost for the waste, so it gives you more points depending on the type of waste. Well, this is the object recognition and classification process. So first, we convert to grayscale. Next, we binarize an image with a fixed threshold. And next, we have the feature extraction of the features of that image, of the object. Next, we have the training and classification of the object. So here we only, well, it's very simple, this kind of process. We get the average of the RGB components of the pixel for each pixel. So we convert to grayscale conversion. Next, with the value of the grayscale, we binarize the image with a fixed threshold. So we get the image binaries. Next, we are using to extract the features of each image. We are using the hue moments, 7 hue moments. We chose that because it doesn't matter if the object is rotated to another place. It will give you the same kind of feature. So that's why we use the 7 hue moments. And we only use the first 2 hue moments because we found that it's enough to separate that kind of waste that we are separating. So we don't need any extra features for that. These are the first 2 moments of the 7 hue moments. Next, well, this is the algorithm that we are using to classify the waste, the KNN algorithm. It's very simple. It's most of the simple algorithm for classification. Well, first we determine the parameter K. So depending on this constant, how the algorithm is going to classify the objects. well, we are using like a metric, the Euclidean distance. So we have like well, first we train the system. We train like 100 for each sample of the waste. So next we calculate, we get the features for a waste and calculate the Euclidean distance for all the training data. And with that, we get a lot of distance. Then we sort the distance and see, then we see if what kind, then we see what kind of weight is. So with the value of K, for example, if we have like a plastic bottle, the nearest 2 points to a plastic bottle, with the sample that we get, we are going to classify as a plastic bottle. So depending on the number of K, in this proposal we set the number K line with the number 2. So, and it works very well. I'm going to show you the results that we get. And despite that this is a very simple algorithm, well, this is the hardware interface of our system. Here we have the Atom. We use the RS-232 serial protocol. This is the PCB for that. And also we have the control board that controls the boards of our system. And here we have the results for that, for the classification process. You can see with the only first 2 Hugh moments, we can get very accurate results. As you can see, this is the can that goes together in a specific duration, and also the bottles and the filtering. So depending of the sample that we get, if it is nearest to the filtering of the bottle or the can, is going to be the.
Just a question. If the bottle is in glass or plastic, will be clustered in the same?
Yes, in the same, because we are only taking
the form.
The form, exactly.
That's right.
Yes. We tested the system over 60 test samples and has a percentage of error of 3.30%. So we're very good, despite that the algorithms that we are using are very simple. Well, as a conclusions, well, acceptable results are obtained. Well, usage of light and hard materials are key for a better function of the object recognition, separation, and energy usage. Well, this project has a lot of, some limitation. For example, the system cannot process deformed waste. So if you
squash
the aluminum can, you're not going to identify that as an aluminum can. And the system can only process one waste at a time. Hence, you have to put the waste one by one. So you cannot put a lot of waste at the same time to process. Well, for this version of the prototype, it only separates 3 kinds of inorganic waste: cans, plastic bottles, and plastic pulp. But it can be easily trained to separate all the kind of waste. You only have to train the system to separate the waste that you want. Well, some contribution that future work that we have is like using other classification algorithms that will be tested to compare the efficiency and performance between them. Like, for example, support vector machines, neural networks, and decision trees. Also, other kind of feature extraction, not only for the form, using the bed machine or block extraction. Also, using more sensors to get more features of the object, like infrared camera, will be very useful. And the technology that we use for this first prototype using bed, OpenCV, where we use MVCV is a wrapper for OpenCV for .NET framework. We are using C# programming language. Well, these are some photos of the prototype. Here we have where we deposit the waste. Next we have the runs. So the gates for each kind of waste. So depending of the waste is going to is the gate that will be opened. That's
Okay, thank you very much. Let us go to the questions, please. What?
For classification, you're only using new moments.
yes, we are using one.
I understand that new moments, how we call it, can classify even if the picture is rotate and scale or scale.
If you want, you
Oh.
can ask in Spanish.
Okay.
En Spanish.
He escuchado que los momentos de hook son buenos para si está escalada o rotada o la tienes, pues le haces el espejo. Pero, por ejemplo, si tú tienes el patrón que tienes guardado o que se aprendió al momento de hook, porque tú le enseñaste primero, ¿no?
Sí.
Le enseñaste una serie de patrones para que se aprendan los momentos de hook. Pero si la botella o la lata cuando caen están en cierta forma, no, ¿cómo decirlo? No rotadas o escaladas, sino
O sea, no es simétricas.
no son simétricas o alguno de los, exacto, no son simétricas. Allí ya no quedaría ninguna de las clasificaciones, ¿no? Porque creo que esa es una de las desventajas de los momentos de Q, ¿no? Si la imagen está ligeramente rotada, por ejemplo una botella que te caiga en cierta forma.
Ajá, bueno, es que primero pues, el prototipo está hecho para que los objetos siempre caigan, ¿cómo se dice? Acostados. O sea, no podría pasar eso. Una ventaja del momento del juego también es que pues, si tiene un poquito de ruido, también te impacta. Pues, ¿no?
Sí.
Pero sí evitamos eso, que siempre caigan todos los objetos
Ah, ok.
acostados, para que no suceda eso.